Good morning. This is the last time you'll hear me say that because this is your last set of guided notes for Algebra 2. It's Lesson 8.5, and we're going to be applying the properties to solve logs. It says, I can apply the property of logs to condense logarithmic functions in order to solve the equations. Let's review the last three properties from the last section. The first one is the product property. Log base x of a plus log base x of b equals log base x of a times b, which means you just write the variables next to each other. The quotient property, log base x of a minus log base x of b equals log base x of a over b, written as a ratio or fraction. And number three, the product property, log x times log base b of a means we're going to bring that over and make it an exponent. So it's log base b of a to the x. Okay, it looks like I'm missing a word or a letter in the word steps. Steps to solve logarithmic equations. 1, you're going to condense to a single logarithm. You're going to change to an exponential equation, and you're going to solve. So we're going to be doing 5 or 6 examples here so that you see. I think you're going to like it. So when you solve, it's important to know that logs with the same base on both sides cancel. Okay, so now we're ready to go. Practice. Solve the following equations. The first one. The first equation is 2 times log base 4 of 3 equals log base 4 of x. All right, so what do I notice? I notice I have a number or value in front of log. That tells me it's the power property, and that I'm going to be moving it over here to make it an exponent on the 3. So this becomes log base 4 of 3 to the second power equals log base 4 of x. All right, now we're changing it to an exponential equation and condensing it to a single, and then we're going to solve it. So it says to logs with the same base on both sides cancel out. These are both log base 4, so they're gone. So I have 3 squared equals x, and 3 squared is 9, so my answer is 9 equals x. All right, let's go to the next one. Log base 10 of x plus log base 10 of 3 equals log base 10 of 12. All right, when I see this addition, if I go to my properties, I know this is the product property. And I'm going to rewrite this as, not in highlighter, log base 10 of x times 3. And I'm just going to leave it in parentheses, equals log base 10 of 12. So I look, I have the same log with the same base. So this is x times 3, but we usually write the 3 first. So 3 times x equals 12. And to solve for x, I divide by 3, and x equals 4. Not so bad. All right, number 3. Log base 3 of 5 minus log base 3 of x equals log base 3 of 2. Okay, so I see I have subtraction this time. Subtraction tells me that it is a quotient property. So I keep the log base 3, but it becomes 5 over x equals log base 3 of 2. Then I notice that I have the same log with the same base. They cancel out, and I get 5 divided by x equals 2. So I'm going to have to solve this. To solve this, I'm going to go ahead and multiply both sides by x to get x out of the denominator. Those will cancel, and I'll get 5 equals 2x. But then to get x by itself, I have to divide by 2. So I get 5 halves equals x. So far, hopefully so good for y'all. All right, let's go to number 4. Number 4, 2 times log base 3 of 2 equals log base 3 of x. So I look and in front of my log, I have a value or number that tells me it's the power properties coming over here. I then notice that I have the same log with the same base. They're both log base 3. I'm going to cancel those out. I'm going to get 2 squared equals x, or 4 equals x. Okay, number 5. 3 times log base 10 of x equals log base 10 of 27. That doesn't look like a 10. Let me fix that. So I see I have a 3 as a value in front of the log. That's going to become an exponent on x. So this becomes log base 10 of x to the 3rd power equals log base 10 of 27. I can cancel my log base 10s, they're the same, and I get x cubed equals 27. Well, I have to solve for x. And when I solve for x and it's cubed, to undo something cubed, I take the cube root. And when I take the cube root, it takes that off and makes that x equals, is 27 a perfect cube? Yes, it is. It's 3. Number 6, our final one. 3 times log base 5 of 2, let me write that better, plus log base 5 of x equals log base 5 of 24. I see I have a 3 in front. I also see I have addition. So that 3 tells me it's going to become an exponent. The addition tells me it's going to be multiplication. So we'll do that in a couple steps. So we're going to get log base 5 of 2 to the 3rd power plus log base 5 of x equals log base 5 of 24. Again, addition tells me that I'm going to be multiplying these together. So I'm going to get log base 5 of 2 cubed, which is 8x, equals log base 5 of 24. I have the same log with the same base. They go away. 8x equals 24. Divide by 8. X equals 3. Okay, this is it, y'all. Your last final lesson for Algebra 2. Kind of sad for me, probably happy for you all. Just go to my messages and follow the assignment for the rest of the year. I'm going to miss you all so much. Bye.